Alright, so here's a video of me making the key, and I will be explaining it as I go. This key is also just posted on Canvas. Alright, so the first thing is I will always give you here the balanced equation, that's what it looks like down here, and also the delta H for each one of these. Alright, so this one is pretty easy because it starts with moles, and we just have to get into how much energy. Alright, so if I have 2.00 moles of CH4, all I have to do is do this transfer right here. Notice kilojoules on top, moles on the bottom. So I go moles on the bottom here. I go 890.4 kilojoules for every 1 mole. That's how that transfers to here. Then I use a calculator and I find out that 2 times 890.4 equals 1780.8. At this point, you should recognize a couple things. One thing, 3 significant figures. Also, this is a negative sign. So, 3 significant figures would look like this is my answer. But here's the deal. Notice I did not write this with a negative sign. I wrote it positive, and I want to, because it's how much is given off. So I can say 1780 is released or given off. Okay, so this is a one-step one because I was starting with moles. In this one right here, I have to go, oh, look at this. This is 22.4 grams. So I have to go from grams to moles, moles to energy. So 22.4 grams of CH4 times, I need grams and moles of CH4. So carbon is 12. There are 4 hydrogens. Each one is 1.01. So I have 16.05 grams, and I'm going to be still using that same delta H value, which is 890.4 kilojoules over 1 mole. I check out my units, grams, grams, moles, moles. I'm left with kilojoules. That's how much I want because it's a measure of energy. So I say, okay, 22.4 times 1 times 890.4 equals, divided by 16.05 equals 12, and there's 3 significant figures, so I'm going to say 40 kilojoules is released. Sounds good? Sounds good. Okay, so same kind of thing, but we might be going a little bit backwards here. Now I'm starting with how much is released, and I need to find how many grams. So I'm going to start and go backwards. Well, backwards. I go 23802 kilojoules. I need to multiply it by something that has kilojoules on the bottom and moles on top. Let's look at this thing. Oh, dang, kilojoules and moles. But this number is going to go on the bottom, and the moles is going on the top. One is the moles. The number always stays with this. So that's negative 2030. Now, I want to know how many moles and grams for, what am I even talking about here? How many grams of ammonium nitrate? Ammonium nitrate were used. So that means I'm going to be in the reactants thing, and that's not ammonium nitrate. That must be ammonium nitrate. All right, so that's NH4. NO3. All right, so NH4NO3. Now, this is the molar mass of this one right here. We have 2 nitrogens, we have 4 hydrogens, and we have 3 oxygens. I need to get my periodic table real quick. Bam. Nitrogen is equal to 14, hydrogen is equal to 1.01, and oxygen is equal to 16. So that's 28. 4 times this is 4.04. 3 times 16 is what? 48? 48. I add those together. 28 plus 4.04 plus 48, and I get something like this, 80.04. So now I can say 2, 3, 8, 0.02 times 1 times 80.04 equals, divided by 2030. I have 5 significant figures, so I can say 9. Oop, but I only have 4 here, so I can say 4. Actually, I only have 3 technically because there's no period. So I'm going to say 938 grams of NH4NO3. Sounds good? On this one right here, you're going to have to do a limiting reagent with this and this. All right. On this one right here, you're going to have to do some stoichiometry. On this one right here, it's basically stoichiometry. All right? All right.